All right, here we go. So we're going to let u equal the inside function. So here it is. Let's take a derivative of that. Du over dx is 8x. And let's solve for du. So du is 8x dx. All right, let's take this and rewrite it. So I'm going to say put this 3 plus 4x squared to the 4th power and then x dx. So what I want to do is I want to substitute. So take out and put in. So the only thing that carries along is the integral sign. And I'm going to say, oh yeah, there's the u, right? So this is u to the 4th power. So u to the 4th power. So again, I'm going from all x's, and then I'm going to go to all u's. So I need to take x dx out. And let's look over here. Oh, here's x dx. How about if I just multiply both sides by 1/8? So I get x dx. So x dx comes out, and I put in 1/8 du. So I went from all x's to all u's. So let me get rid of that and get rid of that. So now let's rewrite this so you can, see. I'm going to, something happened there. All right, so now I'm going to take this 1/8 on the outside, u to the 4th du. So this integral sign and du just mean take the antiderivative of what's inside. So that means increase the exponent. So I get 1 over 40, and then put the u back in terms of x's. So 3 plus 4x squared. So that's the answer to example 1. Let's look at this next example. So here looks really similar. So let's see what we can do. So I'm going to say let's let u equal that inside function, 3x plus 4. Then if I take the derivative, I get 3 dx. So I'm looking at this. I can put this in, so I get u to the 4th. This one says I just need something to replace dx. Well, here's dx, so I'm going to multiply through by 1/3. So dx can be taken out, and I can put in a 1/3 du. Again, I'm just going to take the time to rewrite it, u to the 4th du. So this integral sign in du just mean take an antiderivative of that. So I get u to the 5th over 5, and then 1 over 15. Always put the x's back in. So the x was 3x plus 4. So that's the answer for number 2. So example 3 here, I don't really see an inside function. Do you notice in example 1 and 2, they were to the 4th power. So I had an inside. This one does not use u substitution. So be careful not to use u substitution in every single problem. This one, I need to multiply it out. So I can say this is 64x plus 4x cubed, and then I could take the antiderivative. So 64x squared over 2, 4x to the 4th over 4, plus c, so 32x squared plus x to the 4th plus c. So that's the answer for this number 3. Okay, let's move on to example 4 here. So I've got something in the denominator. So I'm going to let that be my u, the inside of that to the 5th power. So, all right, here we go. So I'm going to try to make that a little bigger. I guess it's not going to let me. I'm going to let u equal x cubed plus 4. And then du is 3x squared dx. And if I take this and rewrite it, so I think rewriting it can really help. I have x cubed plus 4 to the 5th power down here. And then this is 3x squared dx over to the side. Oh, will you look at that? This is exactly this. So I can take 3x squared out and put in du. And then I'm looking at, all I carry along is the integral sign. And so now I'm going to put u into here, so I get 1 over u to the 5th. So take this and rewrite this as u to the negative 5. And remember, you increase the exponent. You add 1. And so this would give me a negative 1/4. Put the u's back in to the negative 4 plus a c. And you could write it in the denominator if you wanted to, or not. This just fine.